In this question number 5 of practice exam 2, we are going to calculate the partial derivatives of the square root function. So you should know, and that should be memorized, that square root of anything, whatever that u is 1 divided by 2 square roots of the same exact thing. And then because of chain rule, that thing will have to be multiplied by the derivative. Okay, so we are using this rule, which you should know, to find the partial derivative with respect to x first. I do see the 6 in the front. That's what's called a constant multiple because it's multiplied by the function, and it should always be kept when finding the derivative. So 6 is going to be kept. Then we're going to get 1 over 2 square root of the same exact thing that you have here. So that will not change. And so that's just going to be 3x cubed plus 4y plus x y to the 5. Okay, and then we multiply that by the derivative of the inside. So 3x cubed plus 4y plus xy to the 5th with respect to x. Okay, so first 6 and 2 will cancel and give us a 3. Then again, we're going to get that root, and we will not change it in our final answer. We're going to keep it the way that it is. But now we have to think about what is the derivative of the inside, whatever was under the square root. And here we can see that we have these pluses. So whenever we are trying to find the derivative of some terms that are added, we are just going to take the derivative of each term separately. And remember that as we do, if we are taking the derivative with respect to x, we want to treat y as a number. We treat it as a constant. And derivative of any number, if it's just by itself, is 0. So we need to remember. But if the number is multiplied by a function, then you keep the number, not, don't drop it. So for 3x cubed, this is normal derivative because there is no y in there. So that's just going to be drop the power. So 3 times 3, that'll become a 9. And then decrease the power by 1. So that's a 2. Now plus 4y does not have an x in it. No matter how complicated a term is, if you add or subtract it to a function and it does not have a variable with respect to which you are differentiating, the answer will be 0. Okay, plus, now we have x, y to the 5. So we are taking the derivative with respect to x. We are treating y to the 5 as a number. So whenever the number is multiplied by the function, we just keep it. So we're not going to drop it. We're going to keep that y to the 5. And then derivative of x is just 1. So that's your answer. That's going to be the partial derivative with respect to x. Now, what is going to be partial derivative with respect to y? We do exact same thing. We are going to have that 3 divided by square root because it's the 6 and the 3 will cancel. I mean, the 6 and the 2. But now what we got to do is take the derivative of that, whatever was under the root, but now with respect to y. So what will happen there? Again, each term has to be differentiated separately. So let me just rewrite the root. Okay, now let's look at it. So 3x cubed does not have a y. So whenever a term is added or subtracted and it does not have the variable with respect to which you are taking the derivative, that's just going to be 0. 4y, that's normal derivative. That's just going to be 4. So we keep the number. Derivative of y is 1. Now, x, y to the 5. So now x we treat as a number. And any number when it's multiplied, we keep it. And then derivative of y to the 5 is 5y to the 4th. Okay, so that's it for this problem. But let me verify this just to make sure, in case you don't believe me, that this is right. We got 3x cubed plus 4y. Oops, sorry. I'm looking at the wrong line. 9x squared plus y to the 5. Okay, so that's this one. The other one is the same. And then that's 4 plus 5xy to the fourth. Okay.